Hi guys, and welcome to another lesson regarding storing local data. And in section 3 we saw various strategies for storing data. Earlier in this lesson we saw how an application can be structured in layers with a data layer at the bottom of the stack. That data layer is concerned with managing the core entities of your application. Those core entities are not the only kinds of data you need to store. You often need to store data about the application itself. That configuration data is specific to a single user or perhaps to the local computer system, and hence it is called local data. Typically, it is stored in a configuration file or as environment variables. We saw how to read that data in section 2. In this section, we will consider the various kinds of local data that an application may need to maintain and the options available for storing it. So this is going to be a very lecture type lesson. Applications have several different types of configuration data. Some of it is concerned with getting the application to work in the first place. For example, the network address of a server or the location of the data files. These values are typically specific to a given installation or computer system rather than to an individual user. Other types of configuration data are things like user preferences. For example, the user may have some control over the layout of the user interface, the colors used, the location and size of the windows on screen, and so on. Another common category of user configured data is the selection of helper applications used. For example, the user's preferred text or image editing software. Some of these details could be exposed in a preferences dialog that the user edits and explicitly saves. Indeed, it may even be possible to store different preferences for different usage scenarios for the same application. Other settings may be stored by the application itself so that it can restore itself to the last state when it restarts. These settings might include the last open file, the currently open windows and dialogues, and the screen coordinates of each. The final data type you might want to store is information about how the application is functioning. In particular error conditions or unexpected inputs can be recorded. This is generally known as logging and involves storing information in a log file that can be examined later, either as part of a debug process or to improve effectiveness of the design. So, storing application-specific data. Application-specific data could be stored on the local computer, or it could be stored in a local network location that all instances of the application can reach. This raises the question of how the computer knows where to look. The usual solution is to this problem is to set an environment variable or use a local configuration file stored in the startup folder of the application. This can then be set as part of the installation procedure. It can even be provided as a startup parameter. The advantage of storing this kind of information on the network is that it is shared so that any changes made, for example, if the database is moved, can be detected immediately by all of the installed instances on the network without having to manually reconfigure each machine or user configuration. It also allows for a backup configuration to be available in the event of a system failure, and by changing one environment variable or configuration setting on the local computers, the new central configuration can be accessed via minimal downtime. The physical storage medium is relatively unimportant because the data are relatively static and normally only read once. when the application starts up. A simple configuration file using plain text, XML, or even Windows INI file that we have seen in the earlier sections. In these formats will likely suffice. Python provides tools for creating and reading all of these. So refer back to section 2 for details. And the next point I want to talk about is storing user selected preferences. User preferences are nearly always stored in the local computer and often in a configuration file stored in the user's home directory. Occasionally, applications store user preferences in the main database, especially if the database contains a significant amount of user data anyway. The disadvantage of using the database is that the application can access the preferences only if the database is accessible, which may not be the case if the user is mobile. It is disconcerting for a user to find that the application appears or functions differently depending on whether they are connected to their network or not. Local storage is definitely the preferred option for this kind of data. Locating the data should be straightforward in a standard file name. Should be straightforward if a standard file name is used and the location is the home directory, because the home directory is nearly always obtainable either as an environment setting or as a user database value. So again, see section 2 for guidance on how to determine user details, such as the home directory. The format is normally a text file using either Windows INI or XML format. If the number of settings is very large, a small local database using SQLite might be appropriate, but this would be separate from the main application data store. One other factor to consider when dealing with user preferences is how these are set and modified. If the settings are few and simple in nature, for example Boolean or integer values, then it might be acceptable to generate a default preferences file and ask the users to manually edit the file. This does carry a risk if the user is not familiar with text editors and use a rich format word processor to edit the file. This can render the configuration file unreadable by the application. However, if the users are likely to be experienced in editing text, such as developers or system administrators, then this approach can work well. If the configuration data is not simple or stored in a structured file using XML or similar, then user editing is much less suitable and error-prone. And the preferences dialog needs to be included in the application itself. And storing and naming configuration data. Some operating systems or environments have preferred ways to store information data. Microsoft recommends that Windows application use the Windows Registry, for which Python provides the WinReg module. The registry can store data for individual users or for the computer as a whole. The disadvantage of registry is that it is Windows specific, and if your code is intended to run on multiple operating systems, you need to have two storage mechanisms. So many developers prefer to standardize on configuration files even for Windows. The X Window system has its own configuration database managed via the XRDB program and expects its configurable data in a specific format. The local settings for all X applications are stored in the file .xresources in the user's home directory. Fortunately, if you are creating X-based programs in Python, you are likely to be using one of the GUI toolkits discussed earlier, and they hide these details from you. However, if your application uses X-based programs as helper applications, you may need to read or modify these X configuration files. This should be treated as a scripting challenge, and the principle found in section 2 apply under scripting with Python. Finally, most operating systems have recommended naming conventions for configuration files. On Unix systems, They often start with a period that makes them invisible to normal file listing tools, end with the letter RC, and are typically stored in the user's home directory for user settings, and the application directory for system-wide settings and defaults. For example, the Vim text editor uses the file .vimrc to store user preferences. It is also becoming common for configuration data files to be stored under the hidden directory .config in the user's home directory, and this is the location recommended by freedesktop.org standards. On Windows, the configuration files are usually in Windows ini format and have the extension of .ini. And storing application state. Storing application state is the least standardized form of local data storage. The location and format of the storage is down to the developer. Some applications make the choice of whether to save state a user preference. Others do it automatically, while most do not save state, except perhaps for a list of recently accessed files. You need to decide how much state information you want to store, where to store it, and what format to use. To keep application behavior consistent, you should choose a local storage option so that the application behaves as expected, even when disconnected from the network. However, you need to be careful with error handling, because if the application was closed while online but then open offline, many of the resources previously used may not be accessible. You need to have a working fallback configuration that can be used when things go wrong. The format of the state data is likely to be quite complex because it may involve multiple windows and even tabs and control settings within Windows. This almost inevitably requires a rich storage format such as XML. On the other hand, if you are only saving the open file history, a simple text file may suffice, or you could even append it to the user's preference data in their configuration file. And the last point in this section is I'll talk about is logging error information. You often want to keep a record of unexpected events or inputs so that you can analyze them later. This could be during testing, following a system failure, or even as a continuous improvement activity. The usual way to do this is to record messages in a log file. The log file might be a single file that just grows continuously, or more commonly a file whose name is based on the date. Housekeeping, archiving or deleting of all files. And housekeeping of all files might be done manually, automatically, or via a shell script. Python provides the logging package to assist this process. It can generate standard information in a standard file with different levels of logging. It can flag a message with different category markers like debug, info, warning, error, and critical. The package is very flexible and allows for many different configuration options to control how it works. The basic usage is straightforward, and you can extend its functions as you need them. At the most basic level, you import the module and then call one of several logging methods corresponding to the categories mentioned. So let's try this logging module. Just need to see the typing. to the shouting one. So it's important that you call basic config before using any of the logging methods, otherwise it has no effect and you use the default values. The level setting indicates the minimum level of message that it displayed. Debug is the lowest level, so everything gets printed. In addition to setting the level, you can also specify an output file name. You can also specify the format of the log message, including things like the date of the message, the file and function where it was generated, and so on. The options are all documented in the log records section of the logging documentation. Because the default format doesn't include any date or time information, you usually want to set that, and we can do it by showing an example. I'll just quit and restart the Python interpreter. So you can also use a date FMT argument to basic config to change the date format using the same options we used in time.strf. Let me just clear this out. Just have to think. So there are many other things you can do, but the basic usually is described here and should be enough for all but the largest projects. So I hope you enjoyed this part of the for this section, and next we are going to talk about localization, and see you in the next lesson. Okay.